Hello all my dear students, welcome you to NEET World. So in this session, we will be discussing one of the very important and interesting topic, that is quantitative approach of this electrolysis. So in the last session, we discussed about qualitative approach of this electrolysis, like at a particular electrode, what are the products formed, right? So in this session, we will be discussing about Faraday's laws of electrolysis. So where it will be giving us quantitative approach. It means what is the quantity of a particular substance deposited at particular electrode. For example, what is the amount of copper deposited when it is undergoing reduction, for copper plus 2 to copper. So this reduction takes place at cathode now. So what is the amount of this copper deposited at this cathode? This kind of calculations, this kind of things we are going to discuss in this particular session. Very interesting and important topic. So just follow the session till the end so that you will get clear idea on the quantitative approach of this electrolysis, Faraday's laws. Okay, so now before going to start this session, I just want to announce you about this our upcoming NEET 2026 long term program as well as JEE 2026 long term program. Okay, these batches are specially designed for those who are taking 1 year drop and preparing for this upcoming JEE and NEET 2026 entrance exams. Okay, so here it will be very properly designed, very well structured, and we have well crafted material, so that will be provided to you if you join the session, you join the batch. Okay, so for more detailed information about this batch, just contact to the mobile number scrolling on your screen here. Okay, let's begin our session here. So this is about JEE. So let's begin our session. We have discussed about electrochemical cells, and yesterday we have started discussing about electrolysis and electrolytic cells, right? So what happens? A spontaneous reaction can be processed by using some external electricity. So by passing electric current, we will be doing a spontaneous chemical reaction. That is what we are seeing, this non-spontaneous chemical reaction in this electrolysis, right? So now let us have this quantitative approach or aspect of electrolysis. So yesterday's class we have discussed that. So during this electrolysis process, for example, let us say I have molten, let me check the color. Yeah. So I have molten NaCl solution or fused NaCl solution. Fused NaCl solution I have. So it means, so molten means what? We only have Na plus ions and Cl minus ions in this electrolytic solution, right? So now we have two so in electrolytic cell. So in this cell, what we have? One anode and one cathode electrodes we have. So we know this anode attracts anions, so it is positive charge. So this is attached to the positive terminal of the battery, and then next here we have this cathode which is having negative terminal, right? So now what happens? All the cations will move towards the anode, all the anions will move towards the anode. So at anode, what we will be seeing here at anode? So all the anions, what are the anions here? We have chloride ion is there now, so that will move towards anode. So this undergoes oxidation, like it forms chlorine gas. Okay, so one molecule, one atom if we have, it will be giving half Cl2, or if we have two chloride ions, so it will be forming Cl2 molecule and releasing 2 electrons. So this loss of electrons takes place at this anode. That is what we are saying it as oxidation, right? So now what is the quantity of chlorine deposited? What is the quantity of chlorine gas released at this anode will be discussed under this concept. That is what? Faraday's law of electrolysis. Okay, so now one more thing, at cathode, what is the products found? At cathode we have cathode means what? Cathode, C. So cathode attracts cation, C you can remember like that. Anode attracts anions, like that you remember. So what is the cation here? We have sodium cation. So sodium cation undergoes reduction by taking 1 electron, and deposits sodium metal at this cathode, right? So sodium metal, amount of this sodium metal deposited at this cathode is what is a quantity that will be given from this Faraday's laws. Hope this is clear what we are going to study in this particular session, right now. So now look, so we have first thing is Faraday's first law. So what this Faraday's first law says, the mass deposited, released or produced of any substance during this electrolysis process is directly proportional to the quantity of charge passed through the electrolytic solution. It means, see, the amount of this cathode, what first law of this electrolysis, first law of Faraday says is the amount of the particular substance, here sodium, is deposited at this cathode is directly proportional to what? What is the quantity of electricity you are passing through, what is the charge of electricity you are passing through this electrolytic solution. It means the weight of substance, weight of the sodium or weight of this chlorine deposited at anode is directly proportional to what? What is the quantity of charge you are passing through this electrolytic solution. This is what first law of thermodynamics, first law of this Faraday's says. Okay, hope up to here it is clear now. So let us go into deeper. See, the weight of substance I am writing, I am removing this proportionality and replacing with something called Z here, electrochemical equivalent into Q. So what is Q here? So Q is called charge here. What is the charge you are passing through it? So Q means charge, and weight, WT here I am writing weight in grams. Okay, and what about Z? This is electrochemical equivalent, electrochemical equivalent. Okay, so what is this electrochemical equivalent? So in order to understand that, see, I am writing Z equals to weight by Q. So what is the units for weight? Here you can take grams or kgs, and for charge it will be coulomb. So what is the unit for J here? Z here. So it is gram per coulomb or kg per coulomb. It means the amount of substance. So Z says the electrochemical equivalent I have written now. It means what? The amount of substance deposited, amount of substance means what? Here it is sodium, here it is chlorine, that things. So amount of substance deposited by passage of 1 coulomb of charge. 1 coulomb of charge if you pass through this electrolytic solution, what is the amount of substance deposited is given by this Z. This is what you need to understand. Okay, or 1 coulomb you can write 1 ampere into 1 second. It means when you pass 1 ampere of current through this electrolytic solution for time of 1 second, what is the quantity of that particular substance deposited at cathode or anode is considered as electrochemical equivalent. Okay, hope up to here it is clear. Now let us make it little more clear, or see, right? So weight I am writing. Now this Z is there, electrochemical equivalent. We can write this as its equivalent weight of that substance, okay, by Faraday. Equivalent weight by Faraday I am writing. So Z, in the place of Z I can write, so in the place of Z I can write equivalent weight by Faraday into Q. So like this I can write now. So now this I can further extend. So how can I extend this? So how can I extend this? What do we mean by equivalent weight? So equivalent weight means molecular weight divided by its n factor. So for example, what do we mean by n factor here? So we are talking about sodium now. So sodium plus ion converting into sodium. So what is the charge here? It is having +1 converting into 0. So how many electrons it is taking? One molecule takes one ion takes 1 electron, so its n factor will be 1. So equivalent weight will be equals to molecular weight in case of sodium. Similarly for copper sulfate, here copper +2 converts into copper. Okay, so how many electrons it is gaining? 2 electrons it is gaining. So n factor in this case it will be 2. So now what happens to it is equivalent weight? Equivalent weight equals to molecular weight of copper by its n factor. N factor is 2. So molecular weight divided by 2 gives us equivalent weight of this copper. Like this, you need to understand that equivalent weight means molecular weight divided by n factor, means number of electrons gained or number of electrons lost during the process. Okay, that is what you need to take here. Okay, so now write this. So weight equals to equivalent weight by F, Faraday's, into F means this is a charge of 1 mole of electrons. So charge of 1 mole of electrons, if you calculate, you will get around 96,500 coulombs. Okay, so what is the charge of 1 mole of electrons? It is considered as Faraday, value is 96,500 coulombs. Okay, so here charge I am writing Q as I into T. So what is I here? Current in amperes, T time in seconds. Okay, so I can write the unit coulomb we have now. So I can write this as 1 coulomb equals to 1 ampere into second. Okay, like this we can write. Okay, hope up to here it is clear. So just take a note out of this. Okay, so now we can also change this into some other format. See, weight I am writing equivalent weight. So what is the Faraday value? I told you 96,500 coulombs into I into T. Like this you can write. Okay, so is there any other method we can write these? See, this is a main equation you can consider up to here, or you can consider this is a main equation. So first one, from here we have started now, so consider it as 1 and this as 2. Okay, yeah, so these are the two equations. We will do numericals on this on this topic, so that it will more clear to you, will give more clear cut idea on this topic. So just hold for some time, just listen to me for some times. Okay, so now here I am writing weight. So weight I am writing as it is. This equivalent weight in the numerator I am sending this side. It will become weight by equivalent weight equals to I into T by F I am writing. So weight by equivalent weight means what? See, see, we know weight by equivalent weight means molecular weight by n factor. So I am writing here n factor. So weight by molecular weight is nothing but number of moles. So number of moles into its n factor. So n into n factor is equals to I into T by F. This is another formula you can write. Formula number 3. Okay, so up to here it is clear, I hope. Okay, now for understanding of this, we require to solve 1 or 2 questions, then you will get more clarity on this. Okay, so just write these formulas first, we will go to the questions. So the next, see here we have a question. The number of Faradays required to produce 20 grams of calcium from molten CaCl2. See, for example, I have calcium chloride, CaCl2. So from molten CaCl2, what we require to produce? We require to produce calcium. So we require to produce calcium means, let me change the color here first. So from calcium plus 2 to calcium chloride means plus 2 oxidation state needs to be converted into calcium. So 0. So now here how many electrons it is gained here? Look here. So how many electrons here it is gaining? 2 electrons for one ion. So in order to convert or in order to produce 1 mole of calcium, how many moles of electrons required? For 1 mole of calcium we require 2 moles of electrons are required here. So charge of 2 moles of electrons is how much? So I told you charge of 1 mole of electrons is 1 Faraday, I told you, right? So here how many electrons you are giving? 2 moles of electrons you are giving. It means how many Faradays you are giving? 2 Faradays you are giving. That's it. See, just to take how many electrons you are taking, that many Faradays you take in order to deposit 1 mole of that particular substance. Okay, so 2 Faradays are required to deposit 1 mole of calcium. Okay, so now 1 mole of calcium weight is how much? What is the molar mass of calcium? 40. So 1 mole of calcium I can write 40 grams of calcium is deposited when we pass 2 Faradays. How much quantity they require? 20 grams. So how can we make this? So just take in order by divide by 2, so that you will get 20 grams of calcium. So here also you divide by 2, so it will becomes 1 Faraday of electricity, Faraday of charge is required to deposit or to produce 20 grams of calcium. So what is our answer? So just 1 Faradays, number of Faradays they are asking. So 1 Faraday. So option number 4 is our answer. Hope this is clear now. Ritesh, hi. Yeah. So this is clear or not? Yeah. So now one more question we will solve. So therefore it will give us more clear idea. See, I just want to give here itself one more question on the same model. See, I have AlCl3. So I have AlCl3. Okay. So now, so from this I am passing 2 Faradays of, let us say other ways, I want to deposit number of Faradays required to deposit 9 grams of aluminium. 9 grams of aluminium from this AlCl3. Tell me. So how can we do this? See, just write Al plus 3 means deposit 9 grams. So what is the aluminium here? Aluminium oxidation state is Al plus 3, right? So Al plus 3 has to convert into Al0. It means how many electrons it required? 3 electrons required. It means for 1 mole of aluminium to be deposited, we require 3 moles of electrons. So for 1 mole 1 Faraday. So 3 moles 3 Faradays of electricity is required in order to deposit 1 mole of aluminium. So 1 mole of aluminium is nothing but, what is the atomic weight of aluminium? This is 27 grams of aluminium, right? Okay. So I want to deposit how many grams?
9 grams.
So we want to deposit 9 grams of aluminium. So use unitary method or directly just look the change. So in order to make, we need to divide by 3. So here also just divide by 3. So they will get 1 Faraday. So in order to get 9 grams, we required 1 Faraday or 96,500 coulombs of charge is required. Hope this is clear. So now by understanding of these two, let us move further. Yeah. Look here, during the electrolysis of molten sodium chloride, the time required to produce 0.1 mole of chlorine gas using 3 amperes of current. So you can get an approximate answer, not exactly, at least approximate will get. Okay, see, this is NEET 2016 question. So how can we do this? So molten sodium chloride, okay, time required to produce, they are saying, okay, produce, so Na plus ion sodium chloride. So Na plus ion required to produce chlorine gas. Now let us say
Cl minus.
So Cl minus should convert into Cl2. Okay. So here I am taking 2 moles for understanding. Okay, 2 electrons will be released. Okay, like this we can say. Now in order to produce, so see how many electrons involved here? 2 electrons. So in order to produce 1 mole chlorine gas, how many electrons involved here?
2 Faraday.
2 electrons. It means 2 moles of electrons are involved. So I can say 2 moles of electrons is nothing but 2 Faraday of electricity is required here, or charge is required here. So 2 Faraday in order to produce 1 mole. Okay. So how many moles they are saying in the question? 0.1. So what we need to do? Just divide this number by 10. So here if you dividing by 10, here also you should divide by 10. So here in order to make this 0.1, so just make this as 0.2 Faradays. Right, this like this only, no? This is the amount of charge required. So what we know, weight of a substance is directly proportional to quantity of electricity passed through it. Okay. So what is the quantity we have passed here? 0.2 into 96,500 coulombs. Okay. So we want weight of this substance. Okay, 1 minute. So what we can do here?
Weight equals to EW
So weight equals to E by F into Q. So we have now weight equals to Z into Q. So Z I am writing like this, E by F. Okay. So yeah. So what is our Q value here?
0.2.
So
0.2 into 96,000.
like that you have to write. So weight equals to, so what is the equivalent weight for this? So molecular weight is 71 by
n factor 1.
what they are asking, time required now. So time required is nothing to do. They are, if they ask weight, we should do like this. They are asking about just a time required. So Q is what is the formula? I into T. Okay. If they ask weight, we need to do all these things. Just they are asking about Q now. So take Q is how much? This much. So 0.2 into 96500 coulombs equals to I. How much I they mentioned in the question? 3. So 3 amp into T in seconds. So coulombs, what is the coulombs I can write? Amperes into seconds, right? So we will get answer in seconds. So divide that number by 60 so that you will get T in minute. So you will get, by simplifying this, you will get around 110, like around you will get 108. So your answer will be, nearest answer 110 will be your answer. Hope it is clear what we are solving here. See, this much charge is required. So charge Q is equals to I into T, right? So we need to find this T only in this. So just take Q by I will give you T in seconds and divide that by 60, you will get the answer in minutes. Okay, right. Next. So if they ask for weight, take it like this. Weight, what is the weight of chlorine deposited means? See, mole, this much is produced. So directly we can do that, no issues. Yeah. So look into this question once again. We have one more question from NEET. The number of electrons delivered at cathode during electrolysis by a current of 1 ampere in 60 seconds is. So number of electrons delivered at cathode during the electrolysis. So cathode, what happens? Reduction. During electrolysis by current of, so what we can do? So so first find, see what we'll get, 1 ampere in 60 seconds. So 1 ampere into 60 seconds means what we'll get from here? So we'll get 60 seconds means we'll get 60, charge we'll get as 60 coulombs we'll get, 60 coulombs. We know 196,500 coulombs means we know 1 mole of electrons, right? 1 mole of electrons. So what they are asking, number of electrons delivered at cathode during the electrolysis. So now how many coulombs we are given here? 60 coulombs. Then how many moles of electrons you can take? Okay, so I am writing this as X number of electrons, that is X into 96,500 equals to 1 mole of electron. I am writing it as 6.02 into 10 power 23 electrons into 60, okay, by 96,500 coulomb. Okay, so by simplifying this, you will get one of this option. See, how can we do this? So we will get 0, 0, 0, and here we have 1, 0. So again I am removing, this will become 22, and then next here we have 36 into 10 power 22 divided by 965. Okay, so just look here, nothing to solve because we have 4 options now. So just use, do not solve it more and more clearly. Just see, this is 96 now. So I am removing 2 zeros out of this. So this will become 10 power 20, and I can write this as 9.65. Can I write 9.65? See, 36 by 9.65 means this is almost 10 times now. So can I remove this and put a decimal here? So it is 3.6 means this will be around 3 point, what is the approximate answer? See here, 3.75 into 10 power 20. So without doing any, see.
That 965.
See 965 we have now, see cancelling and all takes time. So 965 I am approximating is to 10, so that I can write it as 36 as 3.6, right? So 3.6 into 10 power 20 I am writing. So 3.6 nearest approximate answer, see this is the only one we have. So you can go with option number 3, right now? Yeah. So this is how you can save your time without simplifying in all. Okay, next question. So do it. The mass in grams of copper deposited by passing this much of current. Okay, so what I told you, 1 Faraday means 1 Faraday we have approximated as 96500, right? So but exact value is this much. If they won't mention in the question like this, you take it like this, or if they mention anything particularly, you take whatever they mention for Faraday. Now read the question and do the answer for.
16487 into 100 gives us charge coulombs. So
Yeah, do it and tell me. I will be waiting.
87 coulombs.
Mass in grams of copper deposited by passing 9.6487 amperes of current through voltmeter containing copper sulfate solution. So in order to deposit copper, so plus 2 to 0. So how many? So 2 electrons are required. So I can say 2 Faraday to deposit 1 mole of Cu. So what they are asking, mass in grams of copper deposited by passing this much of amperes. So just to take how many Faradays it will become, what is the charge it will become. So Q, you just take
964.87 Faraday.
so 964, see what you are saying,
964
see what we have, weight is directly proportional to Q we have now,
ZQ.
ZQ we have, yeah. So what we can do, so Q I am taking here as I into T. So what is the I mentioned here? 9.6487 into 100. So how much it will become? 964.87 coulombs this is. Okay. So now what is its Z equivalent weight by Faraday? So Faraday value is nothing but they mentioned it as, write that. So 96487 into I into T is 964.87. So what they are asking, in grams of copper deposited. Okay. So this how many times I can remove?
0.
Here in the denominator we will get 100. So what is the equivalent weight means? It is its molecular weight. What is the molecular weight of copper? Atomic weight of copper is 63, because they are asking particularly about copper only, deposition of copper.
But
So n factor is 2 into 1 by 100. It is into 1 by 100 it is. So we will get 31.5. So 31.5
into 10 to the power minus 2.
Into 10 to the power minus 2 here we have. So we can write it as 0.315 grams. This is the weight of what? Weight of copper deposited. We have any option? Yes, third option we have, so go with this. Clear now? Yeah. So take a note. Done. Let's move further. Yeah. So first law is over. So we need to understand what exactly second law here. See, in the first law, once again, one more thing I just wanted to tell you. So what is the formula you have finally got? Weight of a substance. Finally what we got, equation number 3 we have written. So weight by weight of a substance is equals to equivalent weight by Faraday's into I into T I am writing. So sometimes they will ask us efficiency. What is the efficiency of that cell, like that they will ask. Okay, input by, I mean you take like that. See, output by input. So you can take like that. You can use the direct formula, or you can use this x by 100. What is the percentage they will ask? So percentage efficiency you will get here x, okay, into I into T, okay, will be giving us weight. So they will give some weight or something like this. They will ask what is the percentage efficiency or something like that. You need to find the value. So this, take this formula as the other one as number 4 for this efficiency. Finding efficiency. Okay. Next, what about this second law of Faraday's second law here we have. So what this says, whenever we have electrolytic solutions connected in series, when like more than 2 or like this, 2 or more than 2 like cells are connected in series, okay. So let us say here they are connected in like this series, like this series connection is there. So now since they are in series connection, whatever the quantity of electricity passed from here, so that will be constant. Now it is same in all these 3 electrolytes. So whenever this Q is same, then the quantity of this particular substance deposited, particular substance from these electrolytic solutions deposited will be having a ratio like this. So what is this? Read once. When equal charges passed through 2 or more electrolytic solutions, these cells are in connection in series, okay, then the mass deposited, then the weight deposited at an electrode will be in the ratio of their electrochemical equivalents, or in the ratio of their equivalent mass. It means weight of substance deposited 1 and weight of substance deposited 2 will be equals to equivalent weight of 1 by equivalent weight of 2. So this is easy to understand, just wait for some time, I will tell you. See, what is the first law of this Faraday we have? Weight is
directly proportional to charge.
So weight is directly proportional to charge we have writing. So from this what we can write? Weight equals to Z into Q I am writing, okay. So for this Z means, again write it once again, what we can write? Z means E
Equivalent
by F.
E by F.
E by F. So E by F I am writing here also. For example, this is for electrolytic solution 1. Similarly for this is for electrolytic solution 1. Similarly for electrolytic solution 2, how can we write? See, for electrolytic solution, a substance is depositing here, its equivalent weight also considered as E1. So now I am taking for electrolytic solution 2, so W2 I am taking 2, I am taking here, which is equals to E2 into Q by F. See, Q is same here and there now, because same, so QF, Q by F here and here same. So what is the remaining things we have? WT1 by WT2 equals to E1 by E2, equivalent weight 1 by equivalent weight 2, like this only we need to understand. Okay, so now tell me, I will be giving you one rough question here, I mean one simple question. So based on that you answer me. See, when a quantity Q amount of charge is passed through electrolytic solution of copper sulfate, same, when a same quantity of Q amount of charge is passed through copper sulfate solution and silver nitrate solution, then what is the ratio of weights of copper, and weights of silver deposited respect to cathodes is, what is the ratio? This is what I am asking. So tell me. So silver 108 you can say. So what is the ratio of their weights we will get? So their ratios will be their equivalent weights, equivalent weight of copper by equivalent weight of silver, right now. So what is its equivalent weight? Means molecular weight of copper
63
by copper sulfate plus 2 converting into 0. It means its N factor will be 2, you should take it like this, into what about equivalent weight of silver? Its molecular weight is 108, you can say. So molecular weight of silver Ag into its n factor is 1. So this is what the molar ratio you will get. Molar ratio, if they ask you molar ratio, so what you can say? Directly you can answer from molar ratio. What I asked here? Weight ratio. So weight ratio means just multiply with their weights. They ask for molar ratio. So weight of copper, take it here. So what it will become? Molecular weight of copper it will become if I send this side. Here in the denominator what we have? Weight of silver, and send this to here, molecular weight of silver. So this is equals to 1 by 2. So now look here, weight by molecular weight. What is that? Weight by molecular weight is nothing but number of moles of copper by weight by molecular weight of silver, number of moles of silver. This is how much? 1 by 2. If they ask mole ratio, you have to do like this. If they ask their weight ratio, so take 1 multiplied with what is the molecular weight of copper we have? 63.5. 63.5. Okay. So what is the molecular weight here? 2 into 108. So you simplify, you will get some answer. That will be the answer for their weight ratio, and this will be the answer for their mole ratio. Hope this concept is also clear. Okay. Now let me check one more question we have. So try to match this last question of the session. See, 1 mole of H2O2, H2O should be converted into O2. So how many Faradays is required? And here also +7 oxidation state converting into, look this, these are important and easy questions. Yeah, so +7 is converting into +2. It means how many electrons here it is participated? 5. So 5 electrons means 5 Faraday. So 5 Faraday means B
A
4.
Faraday.
So for A, -2 converting into 0. So how many electrons?
2 moles of electrons.
So 2 Faradays. Okay. Similarly, for this you tell me.
1 mole of FeO.
Fe 1 mole of FeO +2 is converting into +3. So 1 Faraday. 1 electron. No?
Should also be.
They are asking only about oxygen is -2 charge only. No? They are also -2. There is no change in the electrons of oxygen. Only iron is changing. Okay. So 1 Faraday. So D 1. So look B.
3. D 3 1 Faraday.
Sorry. Okay. D is 1 Faraday. So that is at here only. Yeah. So now tell me. So B4, where we have B4, and the next D3. So D3, where we have D3 here, and C1A2, the next C1. So how do we got for C1 as C for Ca +2 converting into Ca? So how many Faradays? 2 Faradays for 1 mole. They are given how many Faradays, how much they have given? 1.5 moles. So 1.5 means what we can say? For this 3/2 moles of these, how many Faradays are required? That is what they are asking now. So what we can do this?
3 Faraday multiplication.
So for 3/2, so this what we should do?
3 Faraday.
3/2 into
2 Faraday.
2.
2
So 3 Faradays we want. So we got 3 Faradays. So option C as 1. Hope this is clear. So our answer is 2. Okay. I hope session is helpful, and if you required anything to be covered from Faraday's laws, okay, so we have covered NEET questions more specifically in this, and a few JEE questions. Okay, if you want anything to be discussed, you can feel free to write in the comment box, and if you are interested, so just contact us to the mobile number provided for knowing about this long term batches. Okay, so thank you for watching and stay connected with us. Thank you.